So today, as the attendance is very low, also, so I thought we will go with the problem statement for medical devices data set. Okay, yeah, this session is also recorded and it will be shared in YouTube. Okay, so in the same link where the earlier PPTs and the assignments were shared, and I will share you the art programming code also. So yeah, so the background information for this. So this particular case study is taken from the site actually. You can just go and see it. So the background information is that there is a company called as Glumet, a leading European medical devices company that provides technological solutions for healthcare industry. So they manufacture a blood glucose meter, and this glucose meter is essential for determining the approximate concentration of glucose in the blood, and it's used for home blood glucose monitoring. So the challenges here is, the challenges that were faced by the people, okay, at that particular company was the lack of brand awareness, the disjointed customer support services, and rolling out updates and upgrade features. Okay, so the current scenario with that thing, with that company, is that the management has decided to use diabetes data to double down some decisions. Okay, so they wanted to um, get on to these challenges actually. So instead of so the diabetes data, from what they decided to do was that they collected a diabetes data from hospitals and clinics of two different places, and it has been made available, which contains patient information like age, gender, height, and weight. And in addition to this, we also have anamnesis of the patients. So we have diagnosis and results of patients to see whether the patient is diabetic or not. So the management plans to carry about market research. End result will be, once the glucometer awareness and acceptance in this region is matured, they might have an easier time in selling in these countries. Okay, so study questions for that thing. So once you are analyzing a particular data set, it is used for a set of answering a set of questions that will um, improve the sales of that particular company, or which will um, help in getting around with certain challenges that is faced by the company. So right now the study questions are: what are the factors which will make the launch successful? Then, how is the current market different from the previous ones? What are the strategies that we are going to opt in? And what are the operational decisions needs to be made? Okay. So, in they are going to the product launch process starts with following steps, like they are going to collect patient information, then they will carry out a market research on the data they'll be having, then they'll come up with a marketing analysis, and finally they'll come up with a strategy to enter the market. Okay, so the case study is like, first you'll analyze the data. Okay, so in the data there is HbA1c or glycated hemoglobin. So it's usually a test for confirming diabetes. So people with diabetes need to check their glucose levels often, and hence they are likely to buy glucometers for regular monitoring of their HbA1c levels. Okay. Also, it would help pre-diabetes patients to take preventive measures as well. So, when they are trying to market this product, if they are telling about what their present HbA1c level is, okay, and if they are able to suggest some preventive measures as well to help the pre-diabetes patients, then it will be a good thing for that company, and it will be reaching a wider audience of people. Okay, because right now we have glucose meter which will check the fasting glucose or random glucose values. Okay, so you all know that hemoglobin A1C, A1C or HbA1c is like the reflects the average concentration of glucose in blood over the past 2-3 months. So it has certain levels. Okay, so it's interpreted as if you are having an HbA1c value of 5.6 or less, then you will be classified as normal. If you have it from 5.6 to 6.5, you are in the pre-diabetes case. And if it's like 6.5 or more, then it is the diabetic case. Okay. So for that, you look first need to look at the data set. Okay. So right now I have downloaded the data set. Okay. I'll be sharing it in the drive also. So this is a data set that is right now for that particular case study. Okay. So there is the ID, patient ID, then cholesterol values, then glucose values, then HDL, then their cholesterol and HDL ratio, then glycated hemoglobin, the HbA1c, then the location of those particular patients. So there are in two locations actually. Then age, range of the age, then gender, height, weight, frame of the person, then BP, all these things are there. Then the waist, hip, and the diagnosis, all these things are there. And the result, if the person is non-diabetic, then it's 0, and that person is 0, then diabetic 1, and pre-diabetic also right now it's labeled as 1. Okay, so that is how the dataset looks like, and it has about 404 observations. Okay, so right now what we'll start with is that, okay, so I'll just clear everything, all the environments. Okay, and the workspace also. So for this particular analysis, we need to install certain packages. Okay, so let me just go through that. So first we need to load certain libraries, and these libraries are, just wait a moment. So we have to first download some packages. Okay, so the different libraries, when we come across the use of each of these things, we will see what is it's used for. Okay, so right now, so I have just hided the console. Okay, that's okay. So these packages I have already installed, that's why I have commented these lines. Okay, so first we will include these particular libraries. Okay, all these things have different purposes that we will see later. Okay, now our data set right now is in the same path of this program, so we don't need to specify the particular file path where it is located. We just have to call it by the name. So read.csv, diabetes.csv. Okay, so that is the file there, and we'll just view the data set. Okay, so viewing it on, instead of viewing it on the Excel as an Excel file, we will just view it here. So okay, we can see that it has all these different columns: ID, cholesterol, stable cholesterol, HDL ratio, all those things I have said earlier. Okay, and the diagnosis is either non-diabetic, diabetic, or pre-diabetic. Okay, so right, so we'll go back to the program. Now let's have a look at the head of the data. Okay, so in that head of the data, right now we can see that, I mean, it's displaying about 6 of the observations, right? and these six of the observations, all the columns are present. Okay. Now, to know the structure of the data, we will use the str function. So str will give you the structure of the function. Okay. So these are the data frames. There are 403 observations of 21 variables. Then the ID is this much, cholesterol, okay, glucose, HDL, all these different data. So we can see this is how the data is I mean, this is the structure of the data set. You can see that there are certain or missing values present there, right? So missing values are also present. Then there are some categorical values also, right? In gender and all. So you can see int, numeric, character, like that. The structure is shown. Okay. Now back to the program. Now glimpse will give you an organized structure of the data, and this glimpse is present in another package known as dpy lyr. Okay, so in this dplyr function there is glimpse. So when you run the glimpse function, okay, so this glimpse is present in that particular package. If you run that, then what you get is this one. Okay, glimpse will give you this one. It's similar to structure, only it will give you in this form. Okay, rows 403, columns like this. So it's different, and it's present in a different package. Okay, now using the describe function, we can compute the descriptive statistics. So the descriptive statistics will help determine the distribution. So you can see the summary of the data set. So the summary will show you. So this we have seen in last classes also. Okay, right. So it's the ID, then for the ID, what is the minimum, first quartile, median, mean, third quartile, maximum. All these things will be present. So that will be given by the summary. So all these things you have to find or do first time you are encountering a data set. Then describe, if you do. So these functions, some of these functions are present in Python also. So those who are familiar with Python, they might have seen these words, or in Python also. So similar functionality only here. Now data cleaning. So first we have seen how the structure of the data set looks like, its summary, its description, everything we have done. Now we will look at some cleaning operations, right? So cleaning operations usually means getting rid of the missing values, missing rows. Then if some data formatting is required, like if there are different formats. So for example, in gender, if gender is given as male, female, then capital F, capital M, then small m, like that, it represents the uh, same things, but it's displayed or entered in different formats. Okay, so all these different formats need to be changed and made as two categories. Okay, so then another thing will be like if there are some outliers, how to get rid of them. Then if there are certain other problems like duplicate rows or columns, that also you need to remove. Okay, before you do some analysis in the data set. So first what we'll do is like we'll see the dimension. This is the dimension. So dimension of data set 1 will give you the number of rows, and 2 will give you the number of columns. Yes. So then if you, this is the same thing only. Okay, num columns have the dimension of data set 2. And okay, we will see one thing like a repeat function. So if this is run, that means that it repeats the one value 5 times, REP. Okay, so you can see the result here. If you give REP 1, comma 5, it what will do that it will repeat the number 1 5 times. Okay, so what we are doing is that, I mean, we will find out different ways in which we can count the number of missing values in each column. So for that, I have taken the number of columns, right? Number of columns here I am taking by dim of data set of 2. So in that, so I'm getting in num columns the number of columns of the data set. Now I'm creating a new vector, a new variable is there, vector underscore names, which stores 0 repeated the number of column times. Okay, so if I run that, I have the variable uh, vector NAs. Okay, so it's a number, okay, from 1 to 21. And what I'll do is that I'll just, so this right now is our data set for each column. Okay, and column wise I have to see the number of missing values. So finding the number of missing values is by this function called is.na. Okay, so is a function missing, like that you can tell this is that particular function. And is.na a data set of I, for meaning like we have given it inside a for loop. So from for loop for I in 1 to number of columns, which is like 21 will come. Okay, so vector na of I means for, I mean, for 1 it will get the first column. Okay, so I am just putting is na data set of I in this column. If there is any number of missing values, then their sum will be taken and that sum will be stored to the that particular function in the vector na. So I'll just run these particular lines and I'll just print this one. Okay, so you can see here vector NAs, there are 0 1 0 0 like that it's coming. Okay, up to this particular value. So you can see here that there are 262 missing values in these two particular columns. So that columns will be like 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. Okay, so the columns 15 and 16 has maximum number of missing values which accumulates, okay, sorry, accumulates to more than 50% of the data points. Okay, so this particular number is higher number, so it's better to exclude those columns. Okay, so how to exclude those columns? You can just do like delete dataset select of dataset like this. Okay, or you can delete the columns. Okay, so what I'll do is right now I'll do this particular method, right? Data set of data set without the columns 15 and 16. Okay, so now if you look at the data set, this is the data set right now, and the number of columns have reduced. Okay, there were 21 columns earlier, now only 19 are present, right? So now, yeah, I will just print the dimension of that data set also. So the dimension is like 403 19. Earlier it was 403 21. Okay. Now let's remove all the rows containing the missing value. So right now we have removed all the columns. Okay. So now what I can do is just I'll just run this one again, and we can see what happens. So yeah, right now the num columns are less here. Because 2 we have deleted already. So right now this is the current status of the columns. Okay. So anyway, I'll just make it to the initial state itself. So right now you can see since we have removed 2 columns, this is the current state of missing values. Now, so anyway, we can't delete an entire column for this amount of missing values. So what we can do is, let's try to remove all the rows that containing the missing values. Okay, so what we'll do is row dot hash dot na, we will use the apply function. Okay, so the apply function, what it does is that it applies a particular function for your data set which is given. So apply x, if you give, so x is right now our data which is stored in data set. Margin is whether telling it whether it should perform a row wise or a column wise operation. So for row wise, row operation, it should be like 1. Okay, and the function which we have to perform is an a of x for every x. Okay, so we right now we have defined a function like this, right? So this particular function will check if any entry in that particular x will be missing function, and so that we have stored in row dot has dot na, right? Now what we'll do is that, so row dot has dot na, what it gives is that it's a logic actually. Okay, when I put this in the console, you can just see that it's like false, 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 like that it's there. So it means that in all the rows which we are selecting, in look at here right now, so it's like 23, 24, 25, 26, 27, 28, 29. In the 29th row there are missing values. In the first here, if you see, it's like 1, I mean, or you can check it like 12 is here, so 11, 10, 9, 8. Eighth row also there are missing values. Okay, so right now this has the boolean logic of where there are missing values present in the rows. So what you can, to remove those rows, one of the method is like you can just put data set equal to, right now our data set is contained in that particular what you say, that particular name. So you can give data set of, yes, wherever there is no missing values, because row.has.na means wherever it is true. So not equal to this one means wherever that thing is false. That means wherever the missing data is not present. So now we'll be giving that, okay, as the data set. And now if we print the dimension, so earlier there were like 375 observations. If we print that, okay, so I have already run this one. Yes, so if we print it, you can see earlier there were like 403 observations. Now it have come down to 375. Okay, so that means all missing values have been removed. Okay, so again we will have a look at the data set. So right now this is the data set right now. Okay, yes, now analyzing the data. Okay, so for now we have cleaned the data set of whatever things it was having. Now next what we'll do is that we will start the analysis. Okay, so for analyzing the data, let me just bring this down. So first, I mean, we'll use plot functions mostly, okay, to do the univariate analysis of some of the variables. So first we'll find out which variable turns out to be significant for the analysis. Okay, so we begin with an important variable which is GlyHP. So what it is, we will just see here. So right now this is our data set, and GlyHP means HbA1c. Okay, so we'll start with the analysis of that. So first we will plot and see how is the distribution. Okay, so if you plot, I mean, there is an error coming here. Finger margins too large, so that is not a problem. We will expand the margin. Okay, means I will clear the plot again and I will run this one again. Okay, still it's large, so yes, so we will do it again. Okay, you can see it here. So if I do the zoom of this one, you can see These are the, I mean, we have 375 observations that is there in the x-axis, and data set dollar fly HP, glycated hemoglobin or the HbA1c. So its values are shown from like 4 to 16. The index, I mean, the Y label is coming. So you can see most of the people are around like in the 5 to 6 range, and we have some different people. Okay, some observations are there which are higher than that. Okay, so I'll close the plot. So you can see that the majority of the patients have normal level of glycated hemoglobin. Higher levels seem to be spread evenly across the sample size. Right? You can see once again, it's evenly separated. It's not like it's concentrated on some set of rows. It's there till the end of the observations, number of rows. Okay. Now, next we will look at the stabilized glucose levels. Okay. So if you plot that and I'll expand that one, this also is looking like it's evenly distributed. Okay, and around these values are present, around 100 are mostly present, right? So what I'll do is that I'll clear the plots. Yes. So now what we'll see, pattern should match because the end goal is the same. Okay, because those who have some stabilized glucose values, a similar trend will be observed in the glycated hemoglobin also, that is expected. Now we will see the age group, distribution of the age group. So, okay, so the age group also we have from some kind of about like 20, I mean around 20 to up to 80 plus is also there. Okay, so this is also like very distributed from different age group. The sample distribution is evenly spread. Okay, but we have so we can't jump to any conclusions here, but we'll see two variates now. Okay, so right now we have simply seen, so you can just see this for similar things for each of the different data sets, and you can see for each of the variables individually. Now, what we will do is like we will put two variables in a group, okay? So, plot data set dot glycated hemoglobin and the stable glucose. You can see how it looks like. So, you can see here some correlation is observed, right? It's but it's like spreading out actually, okay? At the lower regions, there is some dense distribution. So, they seem highly correlated, and but it's important to understand the scales of glucose. So here right now it's from 4 to 16 and the other one like 50 to 350. Okay, so to have a better picture we want to see who our target customers are. Okay, so we need a colorful visualization. Okay, so for this type of visualization we are using ggplot. Okay, so this ggplot is a particular kind of plotter actually. Okay, if I want to take you to the description, I'll just show you. So ggplot as well as ggplot2 is present. Okay, there are different and guides also for that. Okay, so ggplot2, how the different plots are there, and you can just go through this resource actually to see what is that. So ggplot is made up of these particular components, like data is the raw data that you want to plot. Then geom means geometric shapes you want to visualize the data. The aesthetics, which is given by AES, that pertaining to geometric and statistical objects like color, size, shape, location, and transparency. These are all the parameters of the plots which you are going to plot. Okay. Now, then the scales, which include values for each aesthetic mapping in the plot. Then there are different other systems. You can read through it. Okay. Then theme. like plot, redux, all these things. Okay. So installing will take, like, you can install the packages for ggplot or ggplot2, right? So you can go through this particular site. Okay. So we'll go back to the R Studio. Okay, Vikram, you can just solve for that. Okay. And if you can, this was given, just go through this week's. Okay. Linear regression. Yes. So I think that was week 6, I think, right? What you can do is, immediately, I mean, you can solve it through the theoretical way also. Okay. So, or you can put in the this thing, okay, in R Studio if possible. Okay. And find it out, right? So I have just go through these things. Okay. This is like, you have to just plot that thing, and you have to find a solution for that equation, just like that. Okay. Then you'll find A and B. Okay. So, okay, what can see, so we were looking at this plot, right? So ggplot, and this is the data set. Aesthetics means that which all data we are including in that particular plot. Then stabilized glucose and glycated HP. Color with respect to the diagnosis. So in the environment, you have a particular column called diagnosis, which will tell you whether non-diabetic, diabetic, or pre-diabetes, diabetic actually. So based on that, you have to separate the things, and geom point and geom, actually the geometry which you have to use is a point, and smoothing, okay, as a curve. So if you run this thing, so this is the plot that you'll be getting, right? Okay. So you can see here the stabilized glucose levels is there in the x-axis, glycated hemoglobin is there in the y-axis, and the distribution. Okay. So the distribution you can see here in the green color, it's like non-diabetic people, because it's like around, I mean, less than 5.6, and in this case it's like less than 100, like that values. So they are classified as non-diabetic. Hmm? And the spread of the data, it goes up to this values. Okay. Because the stabilized glucose values has come around 400, but when you looked at the HbA1c value of that particular person, sorry, it was like around 5 points. So this value is like less than 5 actually. Okay. So that's why that particular person is given as non-diabetic. So from this figure you can see, okay, even if the stabilized glucose value was high, it's that person is termed as non-diabetic, since that person's HbA1c value was less, because it's like a 3 month um, aggregate. Okay. Now the next thing, the blue represents the pre-diabetic people, so their values are around like 5.6 to like that. Okay. So that's why we are plotting like this, to see how the data is represented and how it's varied. So kind of state plan relationship is there when you plot the points. Okay. So this is what we'll get from the ggplot. Now how the distribution of the data set is. Okay. So How the data is distributed you can find using plots plot, histograms, or density plot. So for that, first what we need to do is mm, first what we need to do is we need to change the data set into numeric variables. Okay, so right now we'll look at the data set. Okay, um, so in this data set, mm, okay, or we will first, I mean, we will see the we will see what this particular thing looks like. Okay, so we are right now giving it like this. So data set of numeric, so this is like excluding these things. Okay, so if you exclude these things, this is the data set that we'll get. So here you can see, yes, everything, if you exclude that particular columns which are given there. Okay, so for, I mean, like, we'll see the data set once again. So this particular column, that means 1, 2, 3, 4, 5, 6, 7, seventh column, ninth column, and 12th column, and 18th. Okay, so these columns. Okay, and so these columns, removing these columns, I am forming the dataset not numeric. So dataset not numeric, you can see that there are no categories here right now. Okay, and result have been mapped like 0, 1, like that. Okay, so I'm just picking up the numeric values. Now first we will see what age group does our target for customers fall into. So right now I'm using um, an analysis between the glycated hemoglobin values as well as the age. So because we want to find out what are our target customers. So if you do that and expand the plot, you can see the age group right now distributed like this and the glycated hemoglobin like this. So um, you can see the glycated hemoglobin right now is higher for this particular category. So in this particular age group there is a spike actually, right? So it's like from around 50 to 70, 80, like that. You can observe higher HbA1c values. Okay, so we recognize customers are given into different age groups. So we can, in that group you can see that from 20 to 35, from 20 to 35 it's group 1. 36 to 70 you can give like a group 2 because it's a region where there is a high spike, right? Okay, from from 30 35, yeah, to somewhere around here, right? So that's why we are giving them in group 3, and the higher group 71 to 100 days as group 3. The spread of a potential performance is across different age group. We will need to focus on the diabetic, pre-diabetic patients, right? So now we have an analysis on on which age group of patients to be concentrating on. Okay, so that is one analysis that we got, and another analysis is that we need to concentrate on HbA1c values while getting at this analysis. Why? Because in the plot between HbA1c and the stabilized glucose values, we saw that even if the patients, some of the patients or participants were having higher glucose values, they still had lower HbA1c values. So we need to look at those customers. And the next thing is like, mm, we need to see the target customers clearly. So I'm just putting it like this. So color we will put as a factor of the result because result is like 0 or 1. Immediately giving like 0 for the people who are normal, categorized as normal, and one for the people who are categorized as diabetic or pre-diabetic. We have merged those two actually because we need all those. Okay, so 0 means the normal people. Okay, so you can see the normal people falls around, non-diabetic people falls around this particular value, and the one shows the people around this particular, I mean, who are categorized as diabetic or pre-diabetic. This particular region gives pre-diabetic, and above that gives diabetic people. So you can see that distribution here, like this much concentrate, and this curve shows that there is a higher concentration in this particular age group, right? So the target age is around this one, this particular region. Okay. Now again, so group 2 we have already given like this particular age group. So we can see that group 2 is having that higher, I mean, it's possible that we can target those particular age group customers. Okay. Now let's see how the glycated HbA1c and HB and age vary with the frame variable. So frame variable means the body frame actually. So the frame column looks like medium large. So it's like a category. So for that we are taking, I mean the data set is the data, aesthetics this one, and color according to the frame of the people. Okay. And if we do this right now, okay, I'll just zoom this one. So you can see the age group here, the glycated hemoglobin and frame. Okay. So you have some medium frame people in the age group, say around 50 to 70, who are having very high HbA1c values, right? So you can see what frame of people to categorize. So frame, I mean like a smaller frame of people, I think you don't have to target so much because they are lying around the lesser frame. Okay. So even if your frame is larger also, you are having, I mean there is, it's like maybe like in the pre-diabetic stage only. Okay. So you can say that it's not something that you can analyze for getting the target customers. Okay, so we will come to this one later. So some trend, so we have seen some trend that glycated hemoglobin to increase with age, and also some medium and large people are concentrated in the higher levels of HbA1c. Okay, so some small people are still there with higher glycated HB values, but still mm, the small frame peoples are lying around the lower region. Okay, now we'll see the trend with the body weight. Okay, so these are different kinds of analysis that you need to do with the things that you have learned, because in the course that you have learned, you have the seen the theory part. Okay, and with that theory, these are the things analysis you need to do in a data science point of view. Okay, so next we have to find out how the body weight, how it's related with the body weight actually. So if you run this one, this is a paper plot. I have still given the geometry as a point. So we have given frame also as well as the weight also. So how the weight is distributed is like this, you can see size equal to weight. Okay, so this in this GG plot, there is a provision of increasing the size of the geometric point, I mean the geometric shape, according to the weight of the people. So this is what the size equal to weight does. Okay, so I'll just so here you can see that if size is like a smaller point, then it means that the weight is like in this particular region. So it's like 100 like that it's given. We'll see the data set once again. So here we can see the weight is given like this. So this is in name of pounds actually. Okay, not kg. That's why you can see these particular values in that. Okay, so because this is like data set in UK actually. So they use the pound system, FPS system. So that's why you are getting the values in pounds. So we'll go back to the plot. So here you can see the higher point indicates that that weight is like 300. So right now we have created a plot which has information about age, then glycated hemoglobin, then there is information about the weight of the people, as well as there is an information about the frame of the person. Okay, so all this information we have included in one plot using the ggplot function. Okay, so here you can see the weight of the people with the medium, then you can see some higher circles with large. You can also see the frame of the person with the lower weight also, and how everything is distributed according to the glycated HP. So it's quite evident that age group 2 customers have elevated, and they, with respect to large body frame and heavy weight, are having higher thing. Okay, so this age group with large body frame and heavier weight are having the higher HP values. Okay, medium or it's like medium or large. Okay, now so from these particular data that we have seen, we can draw one conclusion is that people with more body weight tend to be more diabetics. Then we can operational decision looking at this plot. So if we club the body weight with the body frame, we can see. So that is what we did last time. Okay. So if I plot this one, this is the plot that looking like. Okay. Body like weight with age. We are just looking. Okay. Now heavy weight is kind of directly proportional to large body frame, right? If you look at this. So heavy weight has large body frame. Okay. Then so right now we have kind of looked at this particular conclusion. Elevated HbA1c with people with large body frame and heavy weight. So that is one of the conclusions that we drew from the plot. Next analysis that we can do is like what gender we should focus on. Okay, so um, for that we will use another package. Okay, so plotly. Plotly is actually there in Python also for the people who have used Python earlier for data analysis. So if you do that, now you can see people like there are higher count of females that are diabetic, non-diabetic, and pre-diabetic. Okay, so this doesn't mean that a particular age group is having more diabetes. This is like there were more number of females who are analyzed in this data set. That's why you are getting a count like this. So this is not a conclusive analysis. Okay, that can also be the reason why there are higher count. Okay, what we can do, we can try this plot again with a ggplot. Okay, and do it like this. Okay, so there are different kinds of showing the plot. So this is like similar plot with ggplot. Earlier we did with ggplotly. Okay, and from the bar plot we can say that, I mean, kind of prone to diabetes in comparison to human. um, then if you see the frame, we are just kind of analyzing different ways. So if you see the frame, then large people in males will have a, I mean, males are having more count with large body frame. Okay, the more number of males with large body frame. So we had earlier seen that large body frame people are having a chance of being in the diabetic region. So that also we had seen earlier. Okay, so let's see the number in percentages. So for that, we will install one package known as vtree or variable tree. Okay, so I'll just install that and I'm restarting R. Okay, so if I do that and just install this, let me see. So there I have to install one more package. Okay, I'll be installing that also. So you can just give it in this way also, right? Like install in this way also, and you can install in this way install dot packages like that also. Okay, so I'll just visualize this one. Okay, so in this particular figure you can see there's 375 observations that we are having. 59 percentage of them are females and 41 percentage of them are males. So this is what the v3 package does. Okay, now, and so this is the gender, and so if you get like this, okay, which gender we should focus on is this one. Then in our data set there is also like location. Okay, so if you do like this one, you can see that here you can see this one, and then after that we have given location also. So for in females, 48 percentage of them are in Buckingham, the rest are there in Orissa. So this is like a tree for gender as well as location. 59% is a good number which tells on which gender we should focus on. Okay, now, so that is how the gender thing. So we have very good information. Our primary focus will be in gender. Male should primarily be in Buckingham, because in this particular thing we saw that about in the males, um, like this one. Okay, it's distributed. So gender location have you seen? Um, in Buckingham, it's like okay. So like this, we'll see another plot. This is the horizontal plot. Okay, so we should see how the data set is located. So we will see just these two sets. Okay, here. Okay, so library. This was okay. Sorry. ggplot I had installed already, but when I restarted, I think it's has gone. Okay, ggplot 2, and okay, so there is different things to be completed. Um, so here, yeah, we were at this position. Can you see that side then in Buckingham and Louisa, the frame of the people? Okay, so different kind of analysis we can do. Okay, so all these things I think if you do with gender and diagnosis, you can see with among the distribution of males and females, you can see that diabetic people are 17 and in this diabetic people are 19. So here you can see in males itself 19 percentage are there for diabetic and 11 percentage pre-diabetic. So it comes to a total of 30, actually 30 percentage in males itself. If you are taking separately females, it's like coming around 26 percentage rather than 30 percentage. So the number of females and males in the distribution, if you can take an account of the number of females are less, that's why higher number of diabetes people were shown. But if you separately see the distribution, you can see that there are males. Percentage of males have in who are diabetic are more. Okay. Now, so these are the different kinds of plots that you can see. Okay. So I think you can just run through this later, all these observations, right? So I'll just clear all the plots. So some strategy and operations we will see. Okay. So in order to come up with a strategy which will take us some operational decision, we are going to transform the result variable. Okay. Which is a binary variable with ones and zeros. We will convert this into a factor variable with values positive, which is diabetic, and negative, which means non-diabetic. Okay. So the dataset dollar result is as factor. We are just result giving this as a result. Okay, and we are giving the levels 1 or 0 for labels positive and negative. So we are creating a new column like that. So we will see what it does. Okay. So we have created the data set here. So we will view the data set. So that is data set right now has a result here, negative, negative, positive, like that. Okay. Now, so we have taken as a factor. Now, before that, we will see the variable which says about the percentage of diabetic and not. So again, we will go to the V tree function and the V tree right now. Okay. Okay. Hmm. So right now you can see this is the percentage. Okay, just showing it. Okay, I'll increase the figure. Percentage of diabetic customers are more. Hmm. Now, to prioritize our acquisitions, then we'll look at the location. So this is particularly like we will see where to focus the things on. Okay, where to focus the sales. Okay, so right now the frame width and height is so much increased. That's why I have to reduce the figure size. Okay, so if you look at here and you can see that this is the location, result and location. Okay. Mm, so that is strategies. Then another thing we can look at based on the result. Okay, so if we combine diabetic and pre-diabetic patients, it's much positive. So the number two. launch the product. Okay, in that particular locations, and in the percentage we can see that Buckingham is the place to start the launch. Okay. Now another thing we can look at is the correlation analysis. So for that, this package is required, but I have already installed it earlier at the initial time. Okay. So if you want to check if that particular package is present every any time, you can just see if that particular package is present. So Data Explorer I have already installed. Okay. So what I'll do is like uh, I'll just plot the correlation between these columns, okay, in that particular data set, and I will see, okay, how is the correlation. Okay, so right now I'll include the Data Explorer library and I'll plot the correlation. So you can see here, this is a correlation matrix. Okay, so features, I just included the columns 1 to 5. That's why it's given like ID, cholesterol, stable glucose, HDL ratio, like that. And you can see the correlation between the um, different columns there, right? Now we have plotted the correlation. Okay. So these are the different analysis that you can do. So right now I'll just I'll share this file with you. Okay. And you can just see, so this is the analysis. Okay, so here in this case study, at the end what you have to see is that what are these all questions are there. Okay, which variable turns out to be significant for the analysis, then how the distribution of the data, what age group does the target customers fall into. So all these things, there are different things. So some of the things I have shown in here right now. Okay, so what we'll need to do is that we can use the similar kind of plots to see information about each of the different columns. Okay, so that we have done. So there is another function where what you can do instead of doing all these things separately, and that is like this create report. Okay, so this create report is there even in Python also. Okay, so if you are doing the data science analysis in Python, there also you will see this particular thing. Okay, so if you run this particular thing for the data set, right, it will create a data profile. So it's like similar to pandas profiling, okay, in Python. So what it will do is like similar to the pandas profiling, here also create report of the data set will create you a data profiling report. Let us enlarge the screen. So this will show you. I mean, we have seen like different things to plot. So you don't have to do any of that separately. This is a complete like function which does it all those things for you. So if you encounter a new data set, if you don't have to see it individually, you can just run the profiling report. Okay, so for those who are not familiar with Python, this particular create report thing is there available in the pandas profiling particular library also, so you can just see in that also. Here also it's available. Okay, so for first what it will do is that it will give you the number of rows, columns, then discrete columns, continuous columns like categorical or numerical, then missing columns. So right now we had kind of removed every missing columns, but still there is one missing column actually. Okay, then missing observations are near there, so complete rows like that. Then the memory usage for different things, all missing columns, discrete, continuous like that. Now then the data structure. So this is the data structure with 19 variables right now because we had avoided two columns, right? So this is how the data is distributed with the different columns right now. Okay. Now we had formed a new column also named positive or negative. Okay. Then missing data profile in the different columns that are present. Okay. So right now in result, we hadn't completely formed that column. That is why 100 there is a 100 percentage result to be removed there. Then univariate distribution. So this is like for age, for all the different columns, it's given. Okay, all column numerical columns it has given the distribution. Then bar chart with respect to the location, the gender. So these are for the categorical columns with the frequency, right? Okay. Then frame, medium, small or large. Then the diagnosis like non-diabetic, diabetic or pre-diabetic. Then a QQ plot. Okay. Here you can see the correlation, right? Hmm. And so the quartile like plot. Okay. Now for the correlation analysis, some incomplete complete rows are there. That's why it's not given. Okay. So what we'll do is like I'll just run the initial data which has been read. Okay, and I'll okay once more I'll do this thing. The full data set I'll read, and then I will do the create report and see how this one varies now right now. Okay, so right now if I do that, um, so now you can see we haven't done any analysis here. Okay, right now. Okay, so missing rows were ones which we have removed there, and here they are automatically removing some rows containing non-finite values. Then the correlation analysis. Okay, because we have done some analysis to the data set. So if you are using the raw data set, this is a correlation. So in the correlation, the higher correlation is given by the red color one. Then 0 means no correlation. Negative 1 means there is a negative correlation. So this color gradient will tell you how the correlation is between the different variables. Then PC analysis, okay, principal component analysis. Okay, this you can refer to that. Okay, how these features are distributed. So this will help you in select for feature selection. Okay, in our later machine learning model. So in this particular course, you had looked at only two methods for um, of machine learning, right? Like logistic regression. So right now, this is like an output which has categorical value. So it will point to a classification, like in this particular data set it's like whether that person will be like non-diabetic, diabetic, or pre-diabetic. Okay, so it's like a classification. So you can use in this particular course. You have right now learned logistic regression as well as k nearest neighbors, class k and classifier. Now there are other things also that you can do, but first, in data science point of view, first you need to analyze how these different things are related. Okay, so after analyzing the different features or columns in the data set, then you can go about classifying the things according to your requirement. Okay, so as soon as you get one new data set, these are the set of things that you need to do. And for making your job simple, this is one particular thing which will show you all the related data about your data set. Okay, so with that, I think I'll just finish the summary class. Please share the code file in the chat at the end of the session. Okay. Yeah, this will be shared in the same Google Drive file. Okay. Mm, which where you had access the, I think you have access the other week's problems, right? So I'll be adding an extra folder for that, and in that you can find this code, okay, that I'll be sharing. You can use the same Google file link. I think you are having that. If you are not having, I'll share that Google Drive link here. Are you having it? So okay, then I think you're not having it. I'll share. Okay, okay, I'll share the link. Okay, let me find it. Mm, so this is, I mean, I haven't right now shared the link for that. So see if you can access this one. Okay. So I'll be sharing you the link of this chat as well as um, just the data set also. So you can just do your analysis with this particular data set. There are a number of case studies that you can try on. Okay. Just go to any of the sites like Analytics Vidya or Code for Geeks for Geeks. Anywhere you can find out the different case studies that you can use. So right now I have used the medical devices case study. Okay, so I think you can catch on from this um, afterwards. Like you can do your analysis with the different things you'll be doing. Okay, so in the programming point of view, you have to, what you have to do is you have to practice this thing. Then only you will be knowing how to use the different packages, everything, right? Okay, so in the course you have learned about the basics and the theory behind. Okay, when you are implementing this in the real case scenarios, real world scenarios, you already have packages which will take care of your different functions. Okay, so you already know the theory. Now you'll have to concentrate on how you'll be implementing it. Okay, so right now in today's class, what I've done is that how the analysis goes on. So when you are getting a data set, how you can analyze the different features, how you can see the correlation. So what features you have to concentrate on different depending on the different problem statement. So the problem statement that we had looked at is like, so for the people who had come up right now, the problem statement was like um, to create brand awareness and to find out who are the particular amount of kind of people that we have to concentrate on to make the launch successful of that particular glucometer. Okay, so this was the problem statement. So at the end of this particular code, we have just analyzed what is the location, different location, how the gender is distributed, how glycated hemoglobin and stabilized glucose are correlated, and how that is correlated with the age. All these things we have seen. So from that, we have to draw certain conclusions. Like you can focus on these particular age groups. You can focus this particular body frame of people. Then you can increase your sales in these particular locations. So right now we had looked at our particular data set had only two locations. Okay, like this is a data set taking from a UK point of view. So it was like having only Buckingham and Louisa. So only two locations they have concentrated on. So one of these two locations they'll be concentrating their sales on. Okay. So likewise, each and every case study will have each and every different types of things that you have to concentrate on and the things that you have to find out to attain that particular problem statement. Okay. So I think you can do your own analysis based on different data set and based on the fields that you're working in. Okay, so if you're working in some different fields, if you're a student in the particular project that you're working on, you can do this particular analysis. Okay, based on the data set you're provided with. Okay, so in the course, we had seen data sets like um, car engine type, like that one data set we had seen, and iris data set. These were all the data sets which were present. So there also some analysis we can do, like for iris, depending on the petal length, we have seen whether it is classified as these different things. So each and every data set that you'll get will have each and its own problem statement. So you have to find that, and then you have to draw your own questions on that data set so that you can achieve that particular challenge. Okay, so that's all for this course actually. Um, Everything is shared. You can just go through the Google Drive for all the information and all the assignments which were solved. And I hope everyone had a good exam today. Okay, and so I hope you had a good learning experience in this particular course. So that's all from my side. Wishing everyone all the best for whatever you are planning to do in your future. Okay, so thank you. So I'll be stopping the session today. Okay, so I hope everyone have understood what I have told. So this recording I'll be uploading shortly, so you can just find out. Okay, those whoever haven't joined for this session can see. All right, so thank you everyone. um just you can give a request in the Google Drive. Okay, so let me see, because we are not allowed supposed to share like that. Okay, let me see. Okay, so everyone have a nice future, and whatever you're trying to learn, practice more in our studio. In every type of programming language you need to have more practice so that you can um, get every analysis done immediately. Okay, so thank you.